Everybody, so we are going to be talking about parallelograms. We're going to be talking about different theorems that apply to parallelograms and also the 4 reasons that we can prove that certain quadrilaterals are parallelograms and vice versa, how to prove. All right, so first things first, we need the definition of a parallelogram. Right? And the way that this is happening is you have your notes folded to the middle, and we've got 6 different flaps essentially that we're working from. Now, the definition of a parallelogram means it's a quadrilateral with both pairs of opposite sides parallel. Right? So I want you to highlight the important words. I'm not having you write as much on this set of notes, but I do want you to highlight so it sticks out for you. All right? So pretty much what this means is that if AB is parallel with DC, this one right here, and BC is parallel with AD, then ABCD is a parallelogram. Now guess what? The converse also applies. So if ABCD is a parallelogram, then AB is going to be parallel with DC, BC is going to be parallel with AD. All right, so you'll want to remember these parallel lines because guess what? You are going to be using alternate interior angles, alternate exterior, same side interior. They're back. They're never leaving. All right, here is the first theorem that we're going to be talking about. And we're going to come back and write something on the front right here, but not yet. All right, so if an angle of a quadrilateral is supplementary to both of its consecutive angles, then the quadrilateral is a parallelogram. All right, and the converse for this one also holds true. All right, so if the measure of angle A plus the measure of angle B is 180, the measure of angle A and the measure of angle D is 180. Then ABCD is going to be a parallelogram. And like I said, the converse holds true. So if ABCD is a parallelogram, then your consecutive angles, A and B, are going to be 180. A and D are going to be 180. By the way, it also means that B and C would equal 180. But it would also mean that angle C plus angle D would equal 180. All right, so it's great because this opens up a lot of ways for you to solve. All right, so on the front, I want you to go back and I want you to write that the theorem and its converse is that consecutive angles are supplementary. So make sure this is on the front. All right, let's go to the next one. So this states that if the diagonals of a quadrilateral bisect each other, remember that means split evenly into 2. Then the quadrilateral is a parallelogram. So if BE is congruent to DE and AE is congruent to CE, then quadrilateral ABCD is a parallelogram. All right, now you'll notice I haven't been spelling out parallelogram in this. I expect you to. It's just, it takes up a lot of space and we don't have that much space to work with. All right, guess what? The converse is also true. So if ABCD is a parallelogram, then BE and DE are going to be congruent, and so are AE and CE going to be congruent because the diagonals will bisect each other. So this is going to be that the converse is also true. So you guessed it, on the front you're going to write down that diagonals bisect each other. the point of the theorem, and that its converse also work. All right, on to the next one. You might be able to guess what we're going to talk about in this, and you're probably right. If both pairs, this one's super important, of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So if AB is congruent to DC, and BC is congruent to DA, then ABCD is going to be a quadrilateral. And the converse is also going to be true. If quadrilateral ABCD is a parallelogram, then AB and DC are congruent, and BC and DA are congruent. All right, so you guessed it, on the front, we're going to write both opposite sides are congruent, and its converse. Now, I know we've been used to having names for all of our theorems. We don't really have names for all 5 of these parallelogram theorems. So I'm probably always just going to refer to them as both opposite sides are congruent, or whatever these words are that we're putting on the front. All right, just a couple more. All right, this one is similar to the last one, but now we're working with both pairs of opposite angles. So if they are congruent on a quadrilateral, then the quadrilateral is going to be a parallelogram. So if angle A is congruent with angle C, and angle B is congruent with angle D, then quadrilateral ABCD is a parallelogram. The converse also holds true. If it is a parallelogram, then angle A and angle C are going to be congruent, and angle B and angle D are going to be congruent. So your theorem and its converse are that both opposite angles are congruent. If you want to put both sets of opposite angles are congruent, you can do that as well. As long as you understand you need to have both. Because you've got one last one that's a little bit different. This one is also debated among sometimes. Some people like teaching it, some people don't, because they're like, no. So hear me out. If one pair of opposite sides of a quadrilateral is both congruent and parallel, then the quadrilateral is a parallelogram. So, if BC is congruent to AD, and, this is important, it also has to be parallel, then ABCD is going to be a parallelogram. And the converse of this also holds true. All right. If it is a parallelogram, then the opposite sides, one pair of them is going to be both congruent and parallel. So make sure that you write this, and notice this is only one set. This is the only one that breaks the rule of the doubles. That and the consecutive angles one. So remember, this is all we've got. They don't really have names. You're going to see them around, but that's it.